Good morning, Ethereum. My name's Justin Florentine. You may know me online as Robocop's Gone Mad. I work for Consensus Software, and I am a dev on the Besu team. I've been an Ethereum core dev for about 4 years now, since the London upgrade. This talk is going to be a little bit of Ethereum, a little bit of software engineering, and hopefully a lot of activism. We are going to talk about extending execution clients. So, real quick, show of hands. How many people have tried to make a plugin for an Ethereum client? Okay. All right. Anything that extends an Ethereum client would count. All right. Now, how many of you have tried but failed? Well, that's good. All right. Now, how many of you have an idea for an extension to Ethereum but don't know where to start? Okay. Well, if you have any friends that do, tell them to check this talk out. Okay, so we're going to go through a brief history. Hopefully, this will be redundant for many of you. This should look very familiar. We talk about this all the time. This is the blockchain scaling trilemma. This is the clearest illustration of Ethereum's technical values. So, where we are constrained by the legs of that triangle, we value decentralization and security over scalability. So, scaling challenges in Ethereum shouldn't be a surprise. Okay. About 2021-ish, we are led to the roll-up-centric roadmap in light of that iron triangle that I just displayed. Around this time, roll-ups were hitting mainnet, and the thought in the dev community was, okay, well, Ethereum can't scale. Maybe we can just punt on it and make it somebody else's problem, right? So the idea is that Ethereum loans the decentralization and scalability, and security, rather, of the L1 to an L2, and then the L2 can focus on scaling. All right. We think of this as modular, right? This is why we started talking about the modular roadmap. And it's because one leg of this triangle was actually replaceable, right? You could swap it out for something else, and you'd still retain all of the value that the other aspects of the system are giving you. Okay? The TLDR here is free stuff. Okay? A good example of this, I don't know if it's good, but it's an example of this. This is why we have an onslaught of meme coins. All right? Because now you don't need to spin up miners like you did with Dogecoin. All right? Now, for the price of gas to deploy your contract, you get $100 billion of economic security for free. Okay? I am so sorry, but that's the problem. Now, so that was 2021. In 2022, we have another example of modularity. We have the merge. All right? Do people recognize this? Who here likes pandas? All right. All right, panda heads, good. So when we did the merge, we abstracted out consensus and created a way for the execution clients to be driven by another module, all right, the consensus client. All consensus clients drive an execution client through the engine API. All right, this is a common universal definition of the consensus concern in Ethereum. So on mainnet, we are now on proof of stake, and proof of stake drives the engine API. Now, mainnet is not the only EVM network, and other networks may vary their means of consensus. So, for instance, ETH Classic is still out there. They still use proof of work. Folks like to run private chains. Private chains can use different types of proof of authority. All right, IBFT, QBFT, click, et cetera, et cetera. The engine API now can be broadly useful to multiple types of consensus. So, 2 examples of modularity, and 2 examples of how the roadmap for Ethereum is pushing client architectures towards more and more modularity. So, let's see what that looks like. This is a software diagram. This is Geth. Okay? Boxes, lines. Folks should have seen things like this before. Here's another one. This is Besu. This is the one that I work on. All right? More boxes, more lines. This is Aragon. Aragon takes a slightly different approach. Each of their submodules here are totally decomposable. They can run on different hosts, and they communicate with each other with a well-defined API. So it's a different approach. Very cool, though. And again, we still have modularity. This is Reth. All right, Reth is written in Rust. Reth's modularity comes from the libraries that they provide. And each of these libraries is independent, can be reused, can be pulled out, can be run on its own. All right, so again, modularity, similar subdomains, different expression of the modularity. Okay, so I asked the Nethermind team, I said, hey guys, does anything like this diagram exist for Nethermind? This is the Besu diagram. And Lukas, one of my colleagues, said, the diagram is generic enough that we could just label it Nethermind, and it would be quite accurate. So I thought that was funny, and in hindsight, it's also a really interesting point, right? Shouldn't all Ethereum clients look the same from a logical, semantic perspective? And yeah, he's right. They should all look the same. These are design constraints dictated by the protocol. And so this is the price that you pay for consensus. Right? All of these clients all do the same thing. They do Ethereum. And they do it really the same, like cryptographically provable the same. All right? They each have the same problems. Ethereum's peer-to-peer. They all have to have a discovery network. They all have to have a network module, right? Ethereum accepts inputs from users in the forms of transactions, which have to propagate across the network, and all the clients have to retain those transactions so they can propose them. So everybody has a transaction pool. Right? Ethereum is a big old state machine, so it has an EVM. Everybody has an EVM. You have to be able to execute it and calculate your state root. And they all have some sort of RPC layer in, so folks can actually interact with it. You need to have a dApp, you need to have a wallet, something like that. How do you get the thing that you want to do, that being the transaction, into the network? We have RPC stacks that do that, and everybody has one. So all clients have these components, and they're just sitting there waiting for you to use them. So I'm going to beg the question for a moment, if you will humor me. But Justin, you say, this modularity, this is basic good software practice, right? Any competent software project should have this, which is great for your own developers. It makes their job a lot easier. But how can I use it? How can anyone leverage the modularity that we are building into our clients? So let's go a little bit deeper into a specific client. Again, I'm a Besu dev. I'm going to talk a lot about Besu. But other clients have made decisions in their architectures that are analogous to the ones that I'm going to explain. So, pluggable consensus algorithms. Excuse me. Pluggable consensus engines. Now, we didn't have this at first. We had support for proof of work, Click, IBFT, QBFT, but that logic was kind of spread out, a little all over the place. And as we worked on the merge, we began to consolidate it. And since the Ethereum roadmap had given us the engine API, we were able to abstract it out. The engine API is already being used by other forms of consensus, not just mainnet proof of stake. So if a rollup can do it, you can do it too. Now the EVM. This one is very modular, right? This is so modular it can actually run outside of Besu. EVM execution tracing is pluggable. We're adding pluggable opcodes into the EVM. And these architectural choices are driven pretty directly by the needs of rollups. But now that this has been done, you can leverage it as well. All right, transaction pools. Now, shortly after the merge, there was a class of denial of service attacks that had been discovered. Besu was susceptible to it. We created a new implementation of our transaction pool. We called it the layered transaction pool, and it was able to protect us from those attacks. The prior pool was just too easy to pollute. Now, while the new implementation was more robust, it also suffered a performance hit. And not all of our users are running on mainnet. In a less hostile environment, like a private network where you're using proof of authority, this attack is not really relevant. And so those users shouldn't have to take a performance hit. So we made them swappable. Users can swap from the sequential pool to the layer pool. We also added the ability to plug transaction validation in and transaction selection, and we now have transaction bundling as a plugin. So our implementation of the mempool is very, very pluggable, and now you can access it as well. So rewind a second. I was begging the question. The question I begged was, how can you leverage it? And what I want you to take away from this slide is that clients are all in a sort of intermediate state of modularity, and that state is negotiable. Team developers are willing to make changes that will allow people to use their clients for different things. If you don't have access to a thing you want to hack on, reach out to your team. All right, we are adding more and more versatility to our clients to help promote client diversity at the roll-up level. And the use cases are valuable input. So, you're probably tired of looking at this diagram at this point, but one more time. Ethereum clients, moving down the modular blockchain roadmap. They are getting more modular themselves, and as a result, you can change a ton of things. So, what can you imagine? Well, if you take an execution client and swap out the consensus layer, for example, our friends at Linea are working on staked QBFT to decentralize their sequencing. And that drives the execution layer through the engine API. Let's say you want to provide your own EVM execution tracing. Maybe you want to count the number of lines that it takes. Maybe you want to provide your own transaction selection and block building. With those 4 components there, you can build a ZK rollup. And Linea is doing this today. You can keep going with this. After playing with it, you might find out that you'd like to swap out the transaction pool, or maybe the storage representation. Maybe even have custom opcodes that you want to throw in there. This is what Linea is doing. All right? Now, they started with a fork of Besu. And then in collaboration with us, we took their needs and we satisfied them through the plugin API. And now they have everything that they need to run a ZK rollup. They can run their L2 on both Geth and Besu. And there's no reason any other rollup couldn't do this with any other client. We can have client diversity at the L2. And all without needing to really maintain a full fork of the client. So, you're all here because you are participating in Ethereum. Go build a plugin, or a module, or a library, or an execution extension. There will be a way. Client devs can help you find that. All clients have modularity. So, story time. Gather around. Come to the campfire. Once upon a time, there was an Ethereum user. And the user had a problem. The user wanted to be able to see the results of multiple contract calls all within the same block. The user had balances of different ERC20 tokens, and they wanted to be able to test out trading strategies. But there was no way to get an Ethereum client to do that. So the problem turned into an idea and a new RPC called ETH multi-call. And okay, that's an idea, that's nice, but action is nicer. And so the user took it upon themselves to create a plugin that executed the multi-call. And the plugin was good. And the developers were glad. And they were so glad that the plugin got promoted into the client. And the developer's time was saved. All right, the feature became tangible. And then when other users and devs saw how it worked, that feature spread out from Nethermind, first to Geth, and then to Reth. And today, there is a proposal to standardize the method called ETHSimulate. Now, that proposal reflects all of the learnings from implementing the feature in different clients. All right, so again, I work on Besu. Besu doesn't have this. We don't have an ETHSimulate implementation. We would love to. It's really good. But just like everybody else in the world, we're busy, right? Everybody's busy. But you can help. You can write a plugin and implement it just like the hero in our story did. You can make Ethereum go faster. And so I'm kind of asking you all to learn from this hero. All right, the next great concept that's discussed in all core devs might come from a solo staker, an L2 developer, or a dApp dev, and modular clients speed up the vetting process. Having a plugin that already does the thing you're proposing makes it far more likely it's going to be included. It's like having a fast forward button on a technical debate, right? Let's just skip to the part where we try it out. So, go make a plugin. Tell your client team what you need from the transaction pool to make some weird MEV searcher or use an execution extension so you never miss another terrible meme coin drop. You have the power to run your own rollup. All right, thanks for your time. I have been Justin Florentine from the Besu team. I'll see you on the internet. Don't go anywhere. Up next is Gary Schulte from the Besu team. He's got a barn burner of a presentation he's going to show us.